Children, today we are going to learn about the Unit 7, an important topic that is thermodynamics. The term thermodynamics means heat, flow of heat. It is derived from the Greek word. Dynamics means flow, so flow of heat. Thermodynamics means flow of heat. So in our daily life, we come across many useful reactions such as burning of fuel to produce heat energy and flow of electrons through circuit to produce electrical energy, metabolic reactions to produce necessary energy for biological functions and so on. So before studying the laws of thermodynamics and their applications, it is important to learn some few terms which are used frequently in thermodynamics. The first one is system and surroundings. What is meant? First of all, the universe is divided into two parts. Number one is system and number two is surroundings. What is system? System is a part of the universe. It is separated from the rest of the universe. See, this is the system. It is separated from the surroundings. So what is surrounding? Everything in the universe that is not the part of the system, that is called surrounding. What is boundary? Anything that separates the system from its surrounding, that is called boundary. This is the boundary. This separates the system from the surroundings, that is called boundary. So for example, if you are giving an example for a system, it may be a water in a beaker. Water in a beaker. This is the boundary. Water kept inside. So this is the system. This is the boundary. Outside the boundary is surrounding. On the basis of the physical and chemical properties, system divided into two types. One is homogeneous, other one is heterogeneous. Homo means same, hetero means it is different. Homogeneous means if the physical state of all its constituents are same means homogeneous. For example, mixture of gases. Heterogeneous, if the physical state of all its constituents is not the same. Example, mixture of oil and water. Oil and water will not mix. They will stand separately in a beaker. Wherever you are keeping it, it stands separately. So next, types of system. Number one, open system. Number two, closed system. Number three, isolated system. What is open system? If the system is opened like this, without closing, this system can exchange both matter and energy. Both it can spend out. Now, closed system, which can exchange only energy, not matter. That is hot water contained in a closed beaker. Heat only transferred to outside, not the water moving outside. Then isolated system, which can neither exchange matter nor energy. For example, thermos flask. Heat and matter will not come outside. That is called isolated system. Open, closed, isolated. So, all living things and chemical reactions in the open system, they can exchange both matter and energy with the surroundings. But in the closed system, only energy can be transferred, not the matter. So, based upon this, some of the properties of the system. First one, property. Property first one, extensive property. Number two, intensive property. Extensive property means the property that depends on the mass or size of the system, which depends on mass or size. Intensive means which is independent of mass or size of the system. Examples of extensive property means volume, number of moles, mass, etc., internal energy, etc. For intensive, which is independent of mass or size, surface tension, density, temperature, boiling point, so on. These are the two properties. Extensive means which depends on mass or size. This is which is independent on mass or size. Now, some thermodynamic processes we are going to learn. The first one is reversible. Second one is irreversible. For irreversible, only one arrow used like this. For reversible, forward as well as backward arrow. For irreversible, only forward arrow. The process in which the system and surrounding can be restored to the initial state from the final state without any change. For example, ice converted into water. Once more, when cooled, water become into ice. That is forward as well as backward. Irreversible, which cannot be restored to the initial state from the final state. For example, burning of paper. When paper is burned, it becomes into ashes. Once more, the ashes cannot be brought back to the paper. That is called irreversible process. So, irreversible means only from the final state, initial state cannot be brought back. But reversible, from the final state, initial state can be reached. That is called reversible process. Next, the other one is adiabatic process. For an adiabatic process in which there is no exchange of heat between the system and the surrounding. So, for an adiabatic process, Q is equal to 0. No exchange of heat between the systems and the surrounding. That is called adiabatic process. Next, isothermal process. Isothermal process is one in which temperature of the system remains constant. It does not exchanges heat with the surroundings. Temperature remains constant. That is dT is equal to 0. Isochoric process. Isochoric process means volume of the system remains constant. That is dV is equal to 0. Volume of the system remains constant. Next, cyclic process. When a system returns to the original state after completing a series of changes, then it is said to be a cyclic process. For example, rainwater. Once more becoming rainwater reaching the sea, once more goes up to the atmosphere, becoming the clouds, once more coming back to the earth. This is a cyclic process. In this process, that is du is equal to 0, dH is equal to 0. U means internal energy, H means enthalpy, heat. dP pressure is equal to 0, dV volume is equal to 0, dt temperature is equal to 0. So for adiabatic process, Q is equal to 0. Isothermal, dt is equal to temperature remains constant. Isochoric, volume remains constant. One more, isobaric process. Isobaric, pressure remains constant, dP is equal to 0. Now, there are two more property, state function, path function. State function, a thermodynamic system can be defined by the four variables: pressure, volume, temperature and number of moles. A state function is a property of the system which does not depend on the path. It depends only on the particular state to which it is reached. Next, path function. Path function is also another property of the system in which it depends on the path by which the system changes from initial state to final state. It does not depend on the state. It depends on the path. Example, work, heat, so on. Children, these are all given in book page number 187 to 190. That is system, surrounding, boundary, open system, closed system, isolated system, extensive property, intensive property, reversible process, irreversible process, adiabatic process, isothermal process, isochoric process, isobaric process. Next, state function, path function, all the definitions you have to learn, whatever I told. System, surrounding, boundary, open system, closed system, isolated system, extensive property, intensive property, reversible process, irreversible process, adiabatic, isothermal, isochoric, isobaric. Next, state function, path function. With one example, you have to learn, you can mark in the book, children.